Well, here we are again with the 1974 VW Karmann Ghia. We mentioned a while back that we were going to add a liquid cooling system for our Curtis 1231C. Due to the hot environment in which we live, the hilly terrain, and the mostly freeway driving, we really need a little additional in the summertime. It's very marginal now. There are occasions where the controller will go to thermal cutback. And so we're trying to avoid that happening. Get a little more longevity out of the controller by running it cooler. So we've come up with this little heat exchanger, and it's simply some aluminum. I believe it's 3/4 of an inch thick, and some tubing. This is a fairly heavy walled copper tubing. It's making 4 passes through the aluminum here. And we're going to place it directly behind the controller. This matches the base of the controller footprint. And so hopefully we'll be able to draw away some heat from the controller. It's mounted on a heat sink now, and that's just barely ample, but not for our hardest and hottest driving and so forth. So by adding this is the reservoir we're going to use with some modifications. We've got a pump and a radiator and some fans. So what we're doing so far is we've removed the side panels, or just our cosmetics here. Got those out of the way. We've detached some of the wiring, the throttle cable, the wiring to the motor. We removed the Garrett supercharger that we use for a cooling motor on the motor here on our Impulse 9. And so all we have left to do is remove the lower terminal strip wires right here, and that will allow us to bring this whole section, it's basically our heat sink, and these 2 little ABS side panels will all come out as one unit. And so I'll disconnect that now, and then we'll be able to take a look at the back side of our heat sink and figure out how we're going to hook up this heat exchanger, and to make sure that we have room. There's a gap here because we mount the heat sink away from the firewall so that we have airflow back there. But I don't remember for sure if we have enough room for this. That's why we made this nice and thin. So we're going to pull that out and take a look. Stay with us. Alright, I've disconnected the wires across the bottom of our terminal strip. There's 10, I believe. Very quick and easy. There were a few other things that I mentioned a minute ago that we disconnected. And basically, I think on this one, yeah, there's 4 bolts, and this whole thing comes out. So I've loosened the bolts, but it's a little bit late using artificial lighting, and so I'm going to call it a day. Tomorrow morning we'll pull out the heat sink and start that process. But I wanted to mention a couple things that I didn't mention when we first started, and that was, whenever you do something like this, you want to make sure that you disconnect the power. Our 12-volt battery has been disconnected, the ground strap has been removed, and our service and emergency disconnect for the traction pack has also been deactivated so that we don't have any power. And this is the most positive cable coming from our pack, marked with the red heat shrink. I've also put electrical tape around that just to make sure that everything is taken care of so that nobody gets hurt. We don't do any plasma welding or anything like that. So anyway, tomorrow we'll pull out the heat sink and let the fun begin. So I removed the heat sink and its components. This is our heat exchanger, and it will go right about like this. And so we can see that we have quite a bit of room behind the heat exchanger here, so there'll still be airflow. We have room to hook our hose connections. I did have to bend those two little brackets out of the way. They are the original spring brackets. We use the gas shocks on the deck lid, so not going to miss that. They could be bent back if desired. But anyway, this is about where this is going to sit, just like that. So let's take a look at where it's going to go on the back of the heat sink. So here's our heat sink removed. Nice thing about having it set up this way is that we're able to quickly and easily remove this from the vehicle. This is the first time it's been removed since it was installed, but it is nice to have the ability to remove it easily. We just simply disconnected the wires on the terminal strip right here. We disconnected our throttle. These go to the motor heat switch, and these two went to the motor. I have them tucked up right there for right now. But anyway, just unbolted the thing and out it came. So let's turn it around and take a look at how this is going to go in the vehicle. That's as far as the vise will go. So here's the back side. This is directly behind our heat sink here. We're just slightly off center, top to bottom, and that's so I can miss this right here. But that ought to work pretty good. And so now we just need to attach the heat exchanger to the back of our heat sink here. And so we'll give that some thought. Then we'll add some heat sink grease. Clean this off, add some heat sink grease to these mating surfaces, and attach it like that. Mount it back in the vehicle and hook up our plumbing. So let's figure out how we're going to attach this thing. Okay, here's the back side of the heat sink with our heat exchanger attached. Just a note, we use a heat transfer compound. Make sure we had a good thermal connection between the heat exchanger and our existing heat sink. And just a note for those of you running brushed DC motors, this is a non-silicone compound. The reason for that is that when silicone is curing, it gives off a gas which is detrimental to the carbon brushes in your series wound DC motor, like the Warp 9 or Impulse 9 that we use. So we use a non-silicone based compound, put a nice even coat between the heat exchanger and the existing heat sink, and just simply attached it with a couple of aluminum angle irons or angles. We just happened to have that in stock, and there was room to put it. So that was an easy way to do it without drilling any additional holes, without removing our controller, so forth. So it's almost dead center. I mean, we're just a tad bit low, maybe 1/4 of an inch low, but pretty good location. Let me show you the front side here. This is the front side with our reservoir mounted. Of course, this is something we bought off the shelf, which was actually for a different application. So we had to add a fitting, and we have it routed to where it'll go where we want it to go. So it happens to be, just as we desired, this is our highest point in the system right here. So that means that the return on our reservoir will be at the highest most point in the cooling system, which will give us a good flow. So it's going to go from here, the bottom of a reservoir, to our pump. The pump's not going to be the lowest point, but it's close. It's about 5 or 6 inches from being the lowest point. It's got a ability for a 10-foot head, so it'll work okay. There it's hanging in the corner here. This is wiring that's just laying there for the moment. But anyway, there's a panel that goes here which will cover that, so it won't be seen. It's on a shock mount, so it'll absorb vibration. Hopefully you won't hear anything. And this is the inlet. So we're going to come from our reservoir right here down into our inlet, and out the inlet here, or out the in the inlet and out the discharge side, and from here it goes to the heat exchanger, and we'll go to the top side of our heat exchanger here. It'll run through the heat exchanger and come out and go to our radiator. The radiator is mounted below the pump on the underside of the vehicle. Let me see if I can get a shot of that. It hasn't been wired yet either. It's just in place. There it is. Aluminum brackets holding it in place. From this side you can see better our fans And so we'll wire that up. So when you turn on the key, the fans will come on. They'll blow air through the radiator. And the plumbing again will come in the one end of the radiator here, comes back out, and from here it will go back up to the inlet side of our reservoir, which was right here. So that was the complete circuit. Out of the reservoir, through the pump, to the heat exchanger, through the radiator, and back. So we're going to install it back in the vehicle now, plumb it, and wire it, and hopefully it gives us the desired results. So let's move forward. All right, we're kind of 3/4 of the way done or more. Got the heat sink just in place, kind of one bolt holding it in place right now. Got the 12-volt wiring hooked back up. Got the pump in its cubby hole with the cover with the lines going through it. And we can see the pump. And let's take a look at the radiator down below. Again, don't have the fans wired yet, but they'll come on when the pump comes on. So it sits at a slight angle here. Should be protected from most road hazards, any issue, but should be a fairly cool spot here. And where the fans will blow the air down, well, basically across, slightly down, to where the hot air should be exhausted away from the back of the car here. So we'll see how that works. The fans really put out a lot of air. I was impressed by how much volume goes through that radiator. So that's what we have there. So let me show you what happens when we turn the pump on. The pump is extremely quiet. You can't hear it at all. You hear our little fans for the controller here, and of course the only thing that you'll hear when we turn on the key normally will be the Garrett supercharger that's cooling our Impulse 9. So here's the shot inside our reservoir. Put a little bit of antifreeze in here just to give it some color more than anything. We don't have issues with freezing temperatures here. And also as a lubricant, but didn't take a whole lot. So anyway, when we turn on the pump now, it's going to spray a little bit. It puts out some pretty good volume. You can see it's churning pretty good, and it'll start to make a mess real quick here. So anyway, seems to work real well. Comes out of the bottom of our reservoir there, goes into our pump, out of the pump, through the top of our heat exchanger in the back there, out of the heat exchanger, down through our radiator, and back up into our reservoir. So there you have it. I've got to wire up the fans and of course tidy everything up here. This is just the rough blocked in here. We need to kind of clean things up a little bit. So the next thing will be, once that's complete, is we'll need to take her out for a spin. The weather's actually cooled down here today and it's supposed to be cool the next couple days. And then we'll be back in the 90s again. But this weekend we have a 3-day hands-on conversion workshop, so I'll be busy with that. Won't have a chance to really go out and test the vehicle. But we will get her buttoned up before then, I hope. And first part of next week we'll test it out and let you know how it does. Well, here it is, all finished. You can see what it looks like put back together. I did take it for about a 25-mile run. 20 miles of that freeway. And I ran it fairly hard. It's a little bit cooler today. We're having a kind of a little weather front go through, and so instead of being in the 90s, it's in the 70s. So to kind of compensate for that, I drove it a little harder. I was running 75 to 80 miles an hour, and unbelievable the difference it made. How much cooler the controller was to the touch, how much cooler the heat sink was, and yet touching the reservoir, it was warm, but just noticeable, you know, not hot by any means. So it appears that it's working really well. I got good airflow out of my fans on the radiator. Everything seems to be working just perfectly. I have a switch right here that allows me to take that out of the system if I ever chose to, and that would shut off both the pump and the fans to the radiator. It seemed to work really well, and then coming back, I was pushing a really strong headwind. Had to give it a lot more throttle than normal to maintain the 70 miles an hour I was trying to maintain. And it rained while I was in town, and just when I first got on the freeway, it rained like crazy. I mean, it was really coming down. And so, kind of answers another question people always ask, you know, how does an electric car do in the rain? Well, this thing was driven in the snow and the rain, but that was the hardest rain I've driven in, I think, in this particular car. It was really dumping there for a while. So anyway, we'll report back at a later date as far as how it does on an extremely hot day. Won't be long, we'll be over 100 degrees. And I have high expectations. I think it's going to just work exactly the way it was designed to work and the way that we hoped it would work. And the only thing that's noticeable that we've done anything different is the reservoir. The heat exchanger, chill plate, whatever you want to call it, it's on the back side just behind the controller. It's not seen. The radiator's tucked up kind of just behind this panel, but on the bottom side of the car, and it's at a slight angle about like this, so that it's not really catching any road debris or anything. It's pretty protected. It's got 2 high volume fans on it, and the pump circulates really well. I think it's the solution to our marginal cooling that we had with just the heat sink alone. The heat sink alone works fine, probably 6 or 7 months out of the year. The rest of the time, if we really push it, we can get the thing to thermal cutback, and didn't want to be going there. So I think this will alleviate that ever happening again. I don't think we'll ever experience thermal cutback, and we'll have our full power available from our little Curtis, which runs a little car like this real well. And it was a fairly inexpensive modification, probably I want to say about $250, $260 worth the parts, maybe a little more, under $300. So anyway, there you have it. And this weekend we have a workshop, so I'm not going to be doing a video, but we'll be answering more viewer questions come next week. As always, thanks for watching.